Hello and welcome to Barkland Labs. This is the Prelab for Terminal Velocity Lab. Uh, Terminal velocity is when velocity of a falling object reaches a point where it cannot increase anymore due to air resistance. So terminal velocity is something that only happens in an atmosphere like Earth. Terminal velocity actually does not occur in a vacuum like outer space where there is no matter to slow something down. You've all done the thing where you put your hand out the window and it flies back because of the air that's rushing past. Well, it's the same idea when you drop an object like a textbook. It gets faster and faster, and then eventually might reach a point, and that's what you're going to determine today, that it can't get any faster because of the air resistance pushing back on that book. The two objects you'll be working with: old science textbook that we do not use anymore, and coffee filters stolen from the teacher's lounge. So, one thing you need to know first off, what I am doing right now is I am duct taping our book shut. It's not because I want to figuratively cut off knowledge from you guys or anything like that. What I'm doing is making it so that the book doesn't fly open as you're dropping it. You remember from when we used the motion detectors already that you want a nice flat surface if possible. So by duct taping it shut, when I drop it, the cover won't swing open, which would give you a bad reading or kind of an irregular surface reading for the lab. Okay, coffee filter, kind of tricky because when you drop it, it tends to not drop a nice perfect straight line. So you might need to do a lot of trials until you get one that falls just right. If you look down here, you will see a little setup that I have made for our motion detector. I might work out something better than those little plastic blocks, but for right now, those plastic blocks are going to serve as, let's see if I can, juggle this. Sorry if you're seasick now. Those plastic blocks work so that when I drop the textbook, it doesn't actually kill the motion detector when I drop that. So I might work out something better than that, maybe a stack of textbooks on either side, something like that. But basically, you do not want to drop a textbook directly onto the motion detector. And you will want to drop that textbook from as high as possible, obviously safely possible. You do not want anybody slipping and breaking themselves open in the context of this lab. The next thing I'm going to do, I'm going to cut off the video and I'm going to go to a screenplay so you can see how we are analyzing this data on your Logger Pro. Now I have opened up Logger Pro. Welcome back to Barkland Labs. You're going to delete your velocity graph. We are measuring velocity, but from the position time graph by drawing a tangent line, which should tell us the instantaneous velocity at any point. And then we are going to change something about the data collection. You can click up there or up here and go to, you can click on that, or you can go to data and or experiment and data collection right here. Either one should get you there. What we're going to do is we're going to jack up that sampling rate to 40 samples per second. That's doubling it. So what that means is it's going to be sending out basically double the sound waves, the ultrasonic waves, to measure position. So go ahead and hit done. By the way, in case you are curious, when I'm on there, you can see that you could actually change how long it's collecting data for. Right now it's doing 5 seconds. You could make that 10, 15, whatever else. The triggering is also not on right now. Triggering is that button that's on the Logger Pro on the motion detector. If you wanted to use that as the way to start your data, you could do that as well with some different stuff there. So I'm going to leave that off. Just hit done. And I've got a little cardboard box here that I'm going to use as my object that I'm dropping for now. And okay, hello Peppy. Sorry about that. We'll go ahead and wait for that to go away. Okay, so we're going to hit collect, and I'm going to drop my cardboard box. Okay, that was not a good trial, so I'm going to go ahead and try that again. It was going to be a good trial kind of right here, and then I maybe didn't do the greatest job of lining it up, so we got that big spike. You want to reject that one. So I'll give it a few more tries. Hopefully it doesn't take us too long. Okay, that one actually looks really nice. What looks really nice about it is that it's a smooth, continuous line all the way down from where I was holding it to where I dropped it. You probably actually want to hold these higher. I might even have you stand on a chair or a table or stool But for the purposes of this, that's what it should look like. And what you're going to do at this point is go to Experiment and Store Latest Run, or you can press Apple L. That's going to keep that on the graph, so now when you press Start, it will be collecting more data over that, and you can keep on collecting more and more runs. So let's go ahead and try one more. Okay, here we go. Okay, that's another one I'm going to throw out. Oops. Okay, that one is probably another one that I would throw out. Well, maybe, because that little bump right there, but that would maybe be close enough. One of the things you might want to try and do is drop them at about the same time from the same height, so they should look pretty similar. You want to get repeatable results, so it looks like you are getting just consistency there. And so now you can go back to Experiment, Store Latest Run, and notice now we've used blue and red already. Now it's going to be a green graph. What it looks like for the color. So now at this point you go ahead and let's go ahead and clear this graph of that. Now you click on your tangent tool and you are going to examine options, make that font larger so you can read it actually. Ignore the green one. Remember that one doesn't exist right now. And while I'm holding the textbook, shouldn't really have much of a slope, and all of a sudden I drop it and the slope is increasing. Take a look at follow the red one along here as I'm talking. So negative 1.08, 1.59, 1.8, 1.9, 2.1, 2.3, 2.7, 2.93. What I want you thinking about is, what does it mean to have a slope that is constant versus a slope that is increasing when you are dropping an object? How do you think you could tell if an object has reached its terminal velocity? Remember, terminal velocity means that the velocity is no longer increasing. It's reached a point where the wind resistance and gravity are kind of in balance or equilibrium, and it can't get any faster. So you're dropping those two objects. I'm going to have you do 5 trials that I want you to store, and you'll show those trials to me. And from that, from some questions I'm going to give you, you will conclude whether or not either or both of those objects have reached their terminal velocity and what that velocity would be. Okay, I hope you have a great fall.